Hi everyone, Sahil from QuickNode here, and today we will see how we can mint cross-chain NFTs. What we will be doing is we will execute the mint function on one chain, which will be Avalanche Fuji testnet, and the NFT will be minted on another chain, which will be Polygon Mumbai testnet. This is possible with the help of Chainlink's CCIP. Chainlink's CCIP, or Cross-Chain Interoperability Protocol, was launched earlier this year at ETHCC. CCIP provides a seamless solutions for token and message transfers between two chains. If you haven't checked the video out on how CCIP actually works, check out the video linked in the info card over here. Before moving to the demo, if you haven't subscribed to the channel yet, please consider clicking that subscribe button. It's just a click for you, but it keeps us motivated to keep creating these educational videos. Now, onto the demo. To mint the NFT across chains, we will have to follow these steps. The first step would be to store the NFT asset along with the metadata on the IPFS, decentralized storage. Then the second step would be to set up the Hardhat and environment variables. Third step would be to set up smart contracts and compile them. Fourth step would be to set up Hardhat tasks, which will be used to deploy smart contracts and to mint NFT. And the fifth step will be to actually mint the NFT. So what we will be doing is we will be uploading this image of a cute dog on IPFS, and we will be using this as NFT. So let's go to QuickNode. We will be using QuickNode IPFS pinning. So let's go to files. Let's just drag and drop the file over here, which is the image. And what we got to do is we will need to copy the IPFS URL. Let's check if it's working. And since this IPFS URL will be uploaded on blockchain, make sure your gateway is set to private. And coming back to the files, let's copy this URL. Let's go to our JSON file or our metadata file. Let's paste the image URL over here. And this will be our NFT metadata file. We will have to upload the NFT metadata file on IPFS as well. So let's do that and upload the metadata file on IPFS. To double check, let's copy the URL of the metadata file, open it, and yes, this was the metadata. So now our NFT asset and metadata are uploaded on IPFS, and now we will set up Hardhat. Go to your terminal, create a directory, go to that directory, and install Hardhat if you don't have it already installed on your computer. This might take some time if you don't already have Hardhat installed. And now let's initialize our Hardhat project. So we will be using TypeScript. So create a TypeScript project. And this is the project root. Yes. Do you want to use QuickNode? Yes. And do you want to install the same sample project's dependencies? So yes. And this will initialize the new Hardhat project. All right, so our project is initialized. Now we need to install few more dependencies. So over here, we are installing the Chainlink CCIP libraries. And over here, we are installing the Chainlink environment variable encryption library. And then over here, we are installing the Hardhat toolbox, which will be used to compile smart contracts. And over here, we are installing the Ethers library, which is used to interact with the blockchain. So let's install these dependencies. All right, so now all of our dependencies are installed and our Hardhat is set up. Now what we need to do is set up the environment variable. And to do that, we will be using Chainlink's environment variable encryption library. what it does is it encrypts the content of environment variables. So even if you by mistakenly share the environment variable, they remain secure. So first of all, we will need to set up a password, and this password will be used to encrypt or decrypt the environment variable. And then we actually set the environment variables. The first one will be the private key of the wallet you want to use for your NFT deployment. Make sure to not use your main wallet where you store all your funds. So this will be the private key. And the second one would be the RPC URL for our destination chain, which is Polygon Mumbai. And the environment variable will be Polygon Mumbai RPC URL. And we can get the RPC URL from QuickNode. So we just go here and copy this, go back, paste, done. And then the last variable would be Avalanche Fuji RPC URL. Go back to QuickNode, Avalanche node, copy the URL, paste it, done, and click enter again, and then set. Your environment variable is now set. If you want to check it, let's open the code base. So this is how the environment variable looks like. As you can see, all the contents are encrypted. So even if you share it by mistakenly, they will be encrypted, and no one else would be able to decrypt these values without your password, which you just set earlier. So now what we got to do is we got to change the Hardhat config files to use the .n variable, which we just set up, and to use the toolbox, to use the task. We won't be needing the task yet because we haven't set up the task yet. So we will be uncommenting this later. And then we are processing the environment variables which we just set, then configuring the chains with the private keys and their chain IDs. So save this. All right. So this completes our second step where we have set up the Hardhat and environment variables. Now coming on to the third step, which is to set up smart contracts and compile them. So let's set up our smart contracts. So we will be needing 4 smart contracts, which will be destination minter.sol, which will help us to mint the NFT on the destination chain. My NFT, which will be the smart contract for NFT minting, like the general NFT smart contract. SourceMinter will be used to mint the NFT on the source chain, and withdrawal sol will be used to withdraw the token. So let's make these directories. We will find all of these smart contracts. We can delete the log smart contract, which is the default smart contract in Hardhat. So let's get the mynft.sol code. And don't worry, all of the examples of codes which we will be using in this demo are linked in a guide in the description below. So I will be just pasting them in the demo to make it a little bit shorter and faster. So this part we have to replace with the URL of our NFT metadata file, or the IPFS URL of our NFT metadata file. So let's just copy the IPFS URL and select this, replace it with our IPFS URL. Then the destination minter.sol, which will be used to mint the NFT on the destination chain, and SourceMinter.sol, which will be used to mint the NFT on the source chain. Then withdrawal.sol, which is used to withdraw tokens. All right. So now our contracts are set. Let's compile them for TypeScript usage, npx hardhat type chain. Okay, so as you can see, contracts are compiled, and once they are compiled, it will create this folder called type chain. And now let's set up the tasks which will help us to mint the NFTs and deploy the smart contracts. But before that, let's quickly create a animation file. So what we will be doing is we will be using this short script to perform loading animations on the command line tool or our terminal. So that's there. And now let's finally create our tasks. So there are a lot of different tasks files which we are creating over here. We will be going through each of them while pasting the code. So these files are created, tasks. The first file is constant.ts, where we have the configuration of our CCIP placed. So what we are saying over here is pay fees in either the native token of that chain or with link token. Then these are just the supported networks. These are the link token addresses on different chains. These are the router smart contract configuration, the address of the router contract, the chain selector ID for that particular chain. So that's this configuration for all the chains over here, all the supported chains. Save the file. The next file will be utils.ts. This file provides utility functions like getting the provider URL, which are the QuickNode RPC URLs, which we just set up, getting the private key, which is also set up in the environment variables, getting the router config, which is set up in the constant.ts file, which we just saw earlier, and then getting the fees paying tokens for our transactions. We set native token and the link token as our tokens or medium of gas payment. So that's what it will get. And it will help us to get all of these values. And then the helper.ts file, which helps us to get the message ID by simulating a call to the router contract. And then the balance of TS, which is used to get the balance of NFTs. And then the cross-chain mint TS, which is the script actually used for sending the message across chains. And it has various parameters like the source blockchain, SourceMinter, destination blockchain, destination minter, paying fees, etc. So this is the script responsible for sending the message across different chains. And then the deploy destination minter.ts, which will help us deploy the destination NFT smart contract. And then the source NFT minter, which will help us to deploy the source NFT minter smart contract. And then fill.sender, which we won't be using, but if you want to use, you can use this file to fund your SourceMinter smart contract, because we will be sending NFT from one chain to another or minting the NFT from one chain to another. The smart contract needs to have some tokens, and you can use this file to send those tokens to that smart contract or fund that smart contract with tokens. So since we selected earlier that we will be using the native token or the link token to pay the CCIP fees, so we will have to fund the SourceMinter smart contract with some funds later. So now the next file will be withdrawal.ts, which will be used to withdraw tokens from withdraw.sol. And now to bring everything together, let's import all the files to index.ts. So that is it. Okay. So we completed this step earlier where we compiled the smart contracts. We also completed this step now where we set up the Hardhat tasks. So now let's deploy the NFTs. But first step would be to deploy the my NFT and destination minter smart contract. For that, we will have to use the destination minter or deploy destination minter task. But before everything, let's uncomment the task which we commented earlier, because now we have tasks and we will be using tasks. So let's go back to our terminal, use npx hardhat deploy NFT minter, and the network would be Polygon Mumbai. All right. So this is our address which is being used to deploy the smart contract. So as you can see, my NFT contract deployed at this address. Let's save this address in this file. Let's go back to our terminal, and destination minter is also deployed. Let's save the address of that as well. All right. So now let's deploy the SourceMinter smart contract with the help of deploy SourceMinter task, and the network will be Avalanche Fuji. So it's attempting to deploy the smart contract. All right, our SourceMinter is deployed. Let's save the address of that as well. Now we have all of our smart contracts deployed, and the next step would be to fund the SourceMinter smart contract, because that smart contract will be deployed on the source chain, which is the Avalanche Fuji chain, and it will be used to pay the gas fee as well as the CCIP fee on the source chain, which is the Avalanche Fuji chain. So it will need some Fuji tokens. So let's send some Avalanche Fuji test tokens to the smart contract. All right, so the transaction is queued, and once the transaction is confirmed, what we will do is we will actually mint the NFT. So in the meanwhile, let's see how we will be minting the NFT. So this will be our command to mint our NFT across chain, and the SourceMinter address will be replaced with this. The destination minter address will be replaced with the actual destination minter address. Let's check if our transaction is completed or not. Okay, looks like our transaction was completed. So we are all good to mint our NFT. And we are also mentioning over here that we will be paying the fee in the native token, which will be the Avalanche Fuji testnet token, have AVAX token. So let's run our mint command. So it's attempting to mint the NFT from SourceMinter to destination minter. All right, so our transaction was successful, and we can check the status of the mint on CCIP Explorer. So you just have to go to ccip.chain.link, paste the transaction hash over here. So as you can see, the status right now is source finalized. So once this status changes to success, our NFT will be minted on the destination chain. Okay, so now you can see the status is success. You might have to wait for 3 to 5 minutes for the status to become success, because the transactions are happening cross-chain, and then there are some security measures and security protocols in the CCIP network which needs to be passed. So that's why it takes some time. To check your NFT, you can go to testnet.rarible.com and go to your profile. Go to your profile and my NFTs, and over there you would see the NFT. So as you can see, the NFT is deployed on Polygon. This is the address of our my NFT smart contract. that's how you deploy a cross-chain NFT or deploy a NFT from one chain to another. So if you learned anything from this video, make sure to hit the like button and let us know in the comment section what's the next topic we should cover. Thank you, everyone.